In this area, we're looking at the area of a region between two curves. If you recall from maths methods when you're working out the definition of the area under a curve, you had a set of axes. So you had the x-axis and the y-axis, and you had some curve with the equation y equals fx. We had a start value, which we called A, and a finish value, which we called B. And you were then working out the area bounded by the x-axis, the curve, and those two values for x, A and B. We would write this as the area is equal to the integral from A to B of fx dx. This comes from working out an infinite number of rectangles and summing them. So fx represents the height of a rectangle. Dx was the width of the rectangles. So when you're working out a rectangle, is its height by its width, and we were adding together an infinite sum of those to get the area under the curve. As I have drawn there, the curve is above the x-axis, so the value of fx will be positive. Dx, the width of a rectangle, in essence, is always positive. So a positive times a positive is a positive value, which gives us our area being positive. Looking at the diagram for the region between two curves, what we have is an upper curve, y equals fx, and a lower curve, y equals gx. When we're working out the area between those two curves, because they have the same start and finish value, and fx is always above gx, we could have worked them out by working out the area under fx from A to B, and then subtracting the area under gx from A to B. The difference between those will be the shaded area. Using your maths methods formulas, because A and B have the same terminals, we can bring them into the one integral and have the integral from A to B of fx minus gx. That is, fx is always above gx, so the difference between them will always be a positive number. So fx minus gx, if you like, is the height of a rectangle, dx is its width, positive times a positive gives you a positive answer. If the values cross, then you will have to find the points at where they intersect. The situation can become more complicated if fx and gx switch positions. So if we were to look at fx, you'll see that fx is on the bottom at some times and at the top at other times. If you were to look at gx, gx is on the top sometimes and on the bottom other times. So they switch positions. So the way in which we deal with that situation normally is we split it up into two areas. So in this case, we have an area between A and B, which I have labelled 1, and we have an area between B and C, which I've labelled 2. If we were going to work this out, we're working out the area between those two curves in this instance. The first thing we would want to do is find the value of A, the value of B, and the value of C. If you're not given those, that is where the two curves equal each other. Let's assume we know those values. The first one then is going to be an integral from A to B. In that region of the graph, you can see that fx is on top and gx is underneath. So in that case, we go fx minus gx, because that will always give us a positive distance. So it will be the integral between a and b of fx minus gx. The second area, you can see that gx is on top and you can see that fx is on the bottom. So we're going to go gx minus fx. Gx minus fx will give a positive value, so a positive height, if you like, for a rectangle, times dx, a positive width, gives you a positive number. If you were to make the mistake of going fx minus gx, because fx is lower than gx, that will actually give you a negative value and give you an incorrect answer.